Today's objective is objective number 9. Describe differences between straight and meandering stream channels and the 3 factors related to stream velocity. Again, you can pause the video and copy down objective number 9, put tomorrow's date, and this will be the objective we will review tomorrow. We will actually use a stream table to kind of go over these notes. And right now I'll take you through some slides that were first done by a couple of former students of mine, Kevin and Pat, and we'll add some notes to your notebook for objective number 9. First, on page 4 in your note packet is the term stream discharge. Discharge refers to the volume of water in the stream at any given location during a specific amount of time. Or in other words, how much water is leaving the stream at any specific time period. You can relate the word discharge to other places that you've heard the word discharge, like maybe a military discharge when somebody's leaving the military. Hospital discharge, they're being let out of the hospital. Even the discharge of a gun, it just means somebody shot the gun. The bullet is leaving the chamber, leaving the gun. It is being discharged. So one more time, the water leaving the stream at any given amount of time, or any time period, is the discharge. The greater the stream discharge, more water, the faster it will go. That's a direct relationship. One thumb up, the other thumb up. And as we know in New York State, springtime is a time for us to have large stream discharge because of all the snow that has melted throughout the wintertime, plus we get all the April showers that bring May flowers. You get a lot of rain, so streams tend to be at their highest, moving the fastest with the largest amount of water in the spring. Stream velocity is also related to the slope, right? The gradient, the steepness of the channel. The steeper the slope, the faster the water will go. So if you look at the diagram down below, in the beginning part of this stream, because it's so steep, the water will go faster. When you get a gentle gradient, the water will go slower. So there is a connection, again, another direct relationship between the gradient, the slope, and the speed of the water, the velocity. Stream velocity also determines the size of the sediments that are carried by the stream. As the velocity goes faster, it will carry more particles and larger size particles. This is another direct relationship. So faster moving streams can move large pebbles, maybe even roll cobbles, but when the water slows down, it can't move as larger stuff. Direct relationship. This graph on reference table page 6 shows that direct relationship. If you look at the line, all right, you can see that this line that I'm coloring red is a direct relationship. The faster the stream, okay, so the greater the velocity, the greater the size particle or diameter that can carry. So in order for a stream to move cobbles, boulders, or even large pebbles, the water has to be going faster. Now when the water slows down, it will drop those particles, right, the larger ones. That is called deposition, right, and the larger size particles will be dropped first. How does the stream carry these? It can carry the smallest stuff in the water, right, either dissolved in solution, okay, or it can float and be suspended, and the larger particles can roll or bounce or slide along the bottom of the stream floor. So there are 3 factors that are related to stream velocity, and all 3 of them are direct relationships. Now, within a stream channel, there will be differences in the velocity of the water. Because of friction on the sides of the stream, the water will slow down. Just like in the picture, you could see that if there's friction, it can block and slow down items that are moving in the channel. So therefore, you would expect the water to go a little slower on the sides, okay, and even along the surface because of the air resistance. So the smoother a channel, the faster the water would be able to go, and the more of like a semicircular shape, the faster the water would be able to go. These diagrams are not in your notes, but you should add them off onto the side of your note packet. basically showing where the water will travel the fastest. In a smooth, efficient channel, like the ones on the right, you would expect the water to go the fastest in the center just below the surface. Right. In the center just below the surface. An X is there to try and show that. Although there's actually blue dots in the diagram if you can see those. Right, so why there? Because again, it's away from the air resistance and it's away from the sides, the friction that will slow it down. What we're going to talk about soon, coming up on the next slide, next couple slides, is how streams will not always go straight. They will meander. That's what the diagram on the left is showing, how it's curving. Right? And in those cases, you tend to see the water move the fastest on the outside of the meander because it is not a straight semicircular shape path. All right, so this diagram is, or photo actually, is showing a meandering stream. So if you look at the bottom, you can see the stream is wandering. That's another word for meandering. So instead of going straight, it curves back and forth. So that is referred to as a meandering stream. The fastest point in a meandering stream, right, is again under the surface, but on a meandering stream, it's on the outside of the curve. So if I was to look at one of these meanders, out here you can see a little bit of white water ripple, right, a little current. On the outside of that stream, that's where the water is going the fastest. Up here, on the outside of this bend, right, that's where the outside of the bend is, that's where the water is going the fastest. Because it's going the fastest, that's where more of the material will be carried. We call that erosion. So the sand and small particles can be carried and moved on the outside of a bend. That's where it goes fastest. Deposition, that's when the water slows down, all right, and is dropped. Deposition is the dropping off of that material that was being carried. That's where the water goes the slowest, and that would be on the inside of the curve. So on this meander right here, over here at the X would be the inside, so you'd expect the water to go slower, drop off more material, and on the outside at Y, you'd expect to be going faster and carrying more material. Now this photo was taken in winter time, right, and you can also see how much ice is being built up on the inside because that's where the water goes slower. It is easier to freeze. What we find is between X and Y, at some point in between there, and I don't know exactly where that is, so we'll put a question mark, somewhere in between, there is a changeover. Right? We just said X, the water is going slower, more deposition. Y, the water is going faster, more erosion. Well, somewhere in between, there's a changeover between those two processes where the water is traveling at just the right speed so that it is depositing some material but also carrying some material away. And where that is in balance, we call that dynamic equilibrium. Neither process is dominant, so there's a balance between those. And we will show you that tomorrow in the stream table demonstration. So again, if we were to compare a straight channel with a meandering channel, what you would see in a straight channel is it would look more of a semicircular shape, smooth bottom. But on a meandering channel, you're going to see it deeper on one side and shallower on the other. So it's not a smooth. Right? The deeper side, right, is where more erosion is going to occur. We'll call that Y. Right, where it's going to go the fastest. And on the inside, it would be shallower because the water is going slower. It's dropping more stuff off, adding stuff to the bottom instead of carving out and carrying it away. So X, you would expect to be shallower on the inside, slower moving water. Y, on the outside, faster moving water and deeper. And those you see on meanders. Here's one more diagram to show that. Right. You can get to see on the blue arrow where the water is going the fastest. So if I follow the blue arrow, the blue line, water is coming down through the middle. On the meander, it goes fastest from the outside, coming back into the middle. It goes fastest on the outside, back into the middle. It's fastest on the outside, back into the middle. So let's use a different color. And let's mark number 1. On the outside, number 1 on the outside, number 1 on the outside. That's the areas where the water is going faster You'd expect more erosion, and you'd also expect it to be deeper. We'll put number 2s on the inside, where you expect the water to be going slower, more deposition. Right, that's why on this diagram they're showing how a little sandbar, a little beach is being formed right at number 2 because the water is going slower, and you expect it to be shallower. If you ever have any issues on trying to figure out which one is the inside and which one is the outside of the meander, here's a little trick you can do. You could try it right now in your diagram. If I follow the red line of the water coming in, I got my green marker showing that, and then I bend. If I'm not sure if number 1 is the inside or the outside, what I can do is as I bend, just come right around and make a circle out of it. And as I come right around and make a circle, right, as you can see this, draw a circle around there, what you're going to see is that one of the numbers is going to be on the inside. Number 2 is. Number 2 is the inside. That's where the water is going to be shallower, going slower, and expect more deposition. So if you have to, try drawing a circle around either of the meanders. Try one more on the second meander. Not quite sure. Is it 1 or 2? Which one's on the inside? Which one's the outside? Well, follow the black line coming around, make that bend, and just circle it right around. Draw a circle, loop around that meander. You'll see 2 is on the inside, 1 is on the outside. So drawing circles can sometimes help you to pick out which part of the meander is the inside, which part is the outside. And that is the end of that objective.